Today we're going to talk about percent composition, so let's go ahead and get started. So before we start, you want to make sure that you're very comfortable with counting atoms because that's extremely important for this unit. If you don't, you might want to review how to count the atoms and figure out how many of each atom are present in an element. So something I want you to think about is if you want to find the percent of pink starburst in a bag, how would you go about doing this? We're going to come back to this question at the end of class today, and I want you to think about this throughout the entire thing. So percent composition describes the chemical composition of a compound. So what is it made up of? Kind of like the class. What percent of the class is boys? What percent of the class is girls? There are 4 steps to find percent composition. The first is to find the total mass of the compound. So this is finding formula weight or molar mass of the compound. The second step is to divide individual element mass by the total mass. The third step is to multiply by 100. And the fourth step is to add the percents together to check your work. Hopefully the percents are about 100%. If they're a little over or a little under, that's okay. Let's do some problems and practice together. The first problem that we're going to do is NaCl. You do want your periodic table nearby so you can check the masses from the periodic table. Okay, so the first step we're going to do is find the formula weight or the molar mass. We're going to list our elements. We have Na and Cl. There's 1 Na and 1 Cl. The next thing we're going to do is multiply times the mass on the periodic table. The mass of sodium on the periodic table is 22.99. The mass of chlorine on the periodic table is 35.45. Okay? All right, then we want to add them together. So 22.99 plus 35.45 is 58.44. And that's AMUs. Okay? The next thing we want to do is divide the individual elements by the total. So let's do sodium first. The mass of sodium is 22.99 divided by the total, which is 58.44. And since it's a percent, you're going to multiply by 100. Chlorine, the individual mass is 35.45 divided by the total, which is 58.44. And then since we want a percent, we're going to multiply by 100. Okay? So now we can put it in our calculator. 22.99 divided by 58.44. You can hit enter, and then you can times it by 100 to get a percent. And we get 39.33%. Okay? So then the next one, we have chlorine. We're going to do 35.45 divided by 58.44. We can hit enter, times 100 to get a percent, and you should get 60.66%. Now you want to add the 2 percents together just to check. So if you add 60.66 plus 39.33, you get 99.99%, and that's very close to 100. Now, if you got 80 or 70% or even 120, you would know that you did something wrong, and you would want to try the problem again. Okay? Let's do another one together. All right. The next problem that we're going to do is CH4. Okay? Our first step is to list the elements. We have carbon and hydrogen. There's 1 carbon, 4 hydrogen. You want to multiply times the mass on the periodic table. The mass of carbon on the periodic table is 12.01. The mass of hydrogen on the periodic table is 1.01. and then we add them together. So 16.05 AMUs. Okay, so now that we have the formula weight or the molar mass, we're going to divide the individuals divided by the totals. So for carbon, our individual is 12.01. Our total is 16.05. And since we want a percent, we're going to multiply by 100. Okay? Our hydrogen is 4.04 as our individual. Our total is 16.05. We're going to multiply by 100 to get our percent. Okay? So let's do carbon first. 12.01 divided by 16.05. We hit enter, times 100, and we get 74.82%. Okay? For hydrogen, we have 4.04 divided by 16.05. We hit enter, we multiply by 100, and we get 25.17%. Now, in order to check our work, we're going to add the 2% together. So 74.82 plus 25.17. When we add the 2% together, we get 99.99%. And that's pretty close to 100, so we're going to go ahead and call that accurate. Let's do one more together. All right, the last one we're going to do together today is C2H6O2. Okay, so the first step is to list our elements. We have carbon, hydrogen, and oxygen. There are 2 carbons, 6 hydrogens, and 2 oxygens. And then we're going to multiply times the mass on the periodic table. The mass of carbon on the periodic table is 12.01. So 2 times 12.01 is 24.02. The mass of hydrogen on the periodic table is 1.01. So 6 times 1.01 is 6.06. And then the mass of oxygen on the periodic table is 16. So 2 times 16 is 32. We're going to add those all together, and we get 0.08, 10, 12, 3, and 3 is 6. So we get 62.08 AMUs, and now we do the individual divided by the total. So carbon, our individual is 24.02, divided by our total, which is 62.08. Since we want a percent, we're going to multiply by 100. Our hydrogen is 6.06 divided by the total, which is 62.08, times 100 since we want a percent. And then oxygen is 32 divided by 62.08 times 100 since we want a percent. So let's go ahead and find our percents. So carbon is 24.02 divided by 62.08 times 100, and you get 38.69. Hydrogen is 6.06 divided by 62.08 times 100, so we get 9.76%. And then oxygen is 32 divided by 62.08 times 100, and we get 51.55%. So if we looked at this compound would be 38% carbon, about 9.76% hydrogen, and 51% oxygen. If we want to check to make sure we're right, we can add the 3% together. So we can add 38.69 plus 9.76 plus 51.55. If you add the 3% together, then you get 100%. Now remember, the percents could be off just a little bit depending on how you round your masses, or you round when you divide. Okay? So let's go back to that question that I posed to you at the beginning of class. Think about finding the percent of pink starburst in a bag. How would you do it? Could you answer this question? Hopefully you can by now. What questions do you have for me? If you have any, please let me know.